Hi there, Turgeon here, bringing you physics from afar. Remember to think, listen, remember to write. This is about skills, number 28 and 29. Let's go. You've seen this one before, I think. A student heats up some water. They're telling you specific heat. You know right away you're going to be using this equation. Remember, there's a skill involved. Find the equation right here. Q equals mc delta T. Boom. That's the heat equation. You need some certain information for that. They give it to you. Specific heat, 200. Sorry, mass, 200. Specific heat, 4.18. Change in temperature is 60. Boom. There you go. It says show work and include units. So make sure you put joules. Remember, joules is the unit of heat. And oh yeah, by the way, they even tell you joule is the unit. Now they don't tell you it's a unit for heat, but there's a little reminder. Then they ask you about what happens to the temperature. If water is boiling, the temperature does not change, although it's still absorbing heat. You do want to mention this is a phase change, and normally the temperature would increase if you add heat, but in this case, during a phase change, the energy is not going into changing the temperature. The energy is going into making the molecules gain potential energy as they get pulled apart to get further apart out of the liquid stage, and we have a boiling phase change. Part C. The amount of energy absorbed by the water after this weird situation. I'm sorry, this is a bad question. This is very strange. They're saying we're not going to change a thing, and what happens? Well, nothing changes. They added some iron, but the water still had the same temperature changes. So the amount of thermal energy that it absorbed is the same. And remember, absorbing thermal energy is just heat. So we have the same mass, the same specific heat, and the same temperature change. So same amount of thermal energy is absorbed. But this time, if we use something instead of iron, we're going to have something that takes more heat to raise the temperature. That's what specific heat is. So you're going to want to define that. Specific heat says how much heat you need to raise the temperature, a certain amount. So this is going to take more heat and therefore more time. Now we got a circuit question. Again, like we mentioned before, you want to ask yourself if this is a series or a parallel circuit. It says compare the brightness when the switch is open. So remember, open means no flow. So the brightness of these two bulbs is the same. It's the same current. They don't even ask you to explain all that, though. You can probably just get the correct answer and say that these are the same. Bulb X and bulb Y, when the switch is closed. When the switch is closed, again, we're just describing. So when the switch is closed, that means it allows current to flow. So bulb X is suddenly going to get all of the current flowing through the circuit. Bulb Y is going to get none. The reason it's going to get none is all the current's going to flow around. So bulb X gets really bright, bulb Y turns off because all the current flows around it. If the circuit functions differently when the switch is open if we add another resistor at point Z. So now we have 3 resistors, 3 bulbs. So there's less current. Now there is less current due to the increased resistance. So every single bulb gets dimmer. Now you could make a strange argument that the new bulb doesn't get dimmer because it wasn't lit up before, it was just sitting on the table, but all the existing bulbs get less bright. They get dimmer. Calculate the current when the switch is open and you got all 3 bulbs. All right, fine. Resistance is 15 ohms. That's the key to this problem. Resistance is 15 ohms. The voltage is 30. Ohm's law. Remember, the equations are right there for you. There's Ohm's law. V equals IR, voltage, current, resistance. It even tells you right here that capital I is current. It's right there. So everything's there for you. It's just a reading test. V equals IR. Plug in V. Plug in R, which is 15. Divide both sides by 15 here to get I alone. Or you can just look at it and you know that I has to be 2. The unit of current is amperes. Amperes is the unit of current. not to be confused with the unit of charge, which is coulombs. So once again, I think I showed you, this is a listening, couldn't prove this, but the video is a listening activity so that you can learn. And the skills, this is about logic, reading, applying your physics knowledge, and using the equation sheet. This has been Physics from Afar.